Attendees are in listen-only mode.
Okay, welcome to follow a webinar about our new version of FEM-Design 25 and a few practical things before we start. So this is a live event, means that you can ask questions. There's a raise hand button and you can type your questions. And if I don't have time or don't know the answer to your questions, I promise to return to you after the webinar. So just if you have any questions, you can type them in the questions box. So this version we are publishing like once a year, and this year this has been like a exception because a lot of our development resources have went to the development of Eurocode Generation 2, and that has been like a big thing for us. So we are not going to publish the G2 Eurocode parts of the software on the first release. We're gonna publish them later, but it means that what you see today is only like a small part what we have developed in this year. So they will come later, and mostly that has consumed a lot of resources. So you might think that okay, why there's like less features this year? Well, there's is not less features. It's just we don't publish it in the first release. And the other big thing what we have done is this new degree of freedom to B models. So all the B models in the software now have 7 degrees of freedom. And that is the new finite element innovation. And also the data model links to Revit and the other software. We can support up to 80 different software with our calculation software. That has been like a strong part of the development this year. And this is the content of the presentation. So firstly, I discuss about Eurocodes and then the new 7th degree of freedom, then custom UI profiles and dialogues, and then a few other improvements, and then a few really interesting things like these parametric automatic parameters and parametric formulas and sections and parametric solids. They are like really can boost your productivity if you know how to use them. And then I talk about those IFC improvements, what we have done, and the Revit link, what is now have been revived again, and a few other improvements, including the new license system. Okay, first about a few words about Eurocode Generation 2. So when you start the new FEM-Design 25, you will see this dialog. It's meant to be there that you can switch between the first generation and the second generation of the Eurocode, and you can see that the second generation is still gray, so you cannot choose it. And we intentionally did so that all the new Eurocode stuff will be published later. So only you can see that you have this pop-up window, but you still cannot use it. But later this year, it will become active. So you can look in the service releases when we start to put out those new Eurocodes. And first release is going to be about the loading, the Eurocode 0, and the general principles like load factors. So Eurocode 1 and Eurocode 0. And later comes the concrete and steel parts. And national annexes still are missing, so that comes later, but probably not this year because even the annexes are not ready. And you have to understand this has consumed a lot of development resources, but the current release does not publish any of this. But it will come. You have to trust us. So first few words about this new 7th degree of freedom. I just had that webinar about this topic, so I'm not going to talk about this a lot today. But if you missed the webinar, few like highlights about the new finite element model, what we did our finite elements over. So this is a totally new in world scale. This is a totally new innovation because usually finite element software have been used 7th degree of freedom model, what is called lasso. So it means that it's mostly like bending theory, and you can see that there's a picture. This is a bending. But of course, the warping also causes shear deformations, and usually that has been neglected traditionally. But now we finally have the theory for warping shear. So traditional warping or 7th degree of freedom theory has been that we just use the bending, but now we also can take the shear parts of the warping into account. So that's new. And what it means that this will be more realistic and it can be used in any section, not just like thin-walled or closed sections. So whatever section you have in your finite element model, the 7th degree of freedom can be turned on for those beams as well. And it's very accurate and also compatible with the Timoshenko because we have the shear deformation component in the beams. And what problem does it solve? So first of all, this our method, it has no shape limitations, it has no model limitations, so anyone can use it. You only need a steel license, and even if you don't have steel license, you can make one beam with the 7 degree of freedom. It's not for special users because you don't have this limitation. So any beam in any model can be turned to 7 degree of freedom beam model. And when do you need it? When the beam have torsion and the flanges have curvature, so it has to be prevented torsion. So that those two criteria what you have been met, and then you can use it. And the second use case is lateral torsional stability problems of any beam, so like upper flange buckling or lower flange buckling and so on. And it's absolutely necessary in I-beams, open sections, and unsymmetrical sections with any loading. Like this example here, you have a C channel section, and if you have any loading, that will cause torsion. So that only works with the 7 degree of freedom beam models, not the traditional beam models. And it also applies to any section as this example illustrates. So if you have like a core wall or shaft, even there you have a warping. And if you turn on the warping, you can see the stresses increase. And same here, it's a closed section, but still the warping has a minor effect on the behavior structure. So you can see that the warping has also meaning in these type of structures. So how do I use it if you want to? Have you? There's a question. Have you started? I can hear anything. Can anyone else comment? Can you hear me? Because I think I should have the voice on. I think there might be that there's something wrong with your voice settings. We can hear you. Okay, thank you. You don't have to. Okay, you have to check your. But anyway, there's a recording of this session, so you don't miss anything. You just check the recording in that case. But anyway, how to use it? You go to the beam properties. So if you go to the properties of the beam, like here, go inside of the beam properties, and then you check that there's a new feature here. You can select that this is a traditional beam or warping beam, and then you have to define this new warping degree of freedom connection to the other members. And then you have a new internal forces. You have Y moment, and the torsion is divided to two components, the Saint Venant and warping. And in the bar stresses, you can also see the effects of warping. So warping will increase or decrease the stresses of the beams depending on the case. And we have also new features here in the internal forces in the right-hand side of the screen here that you can turn on the components of the internal forces. So you can turn on the bi moment or shear or Saint Venant component or normal force, and you can really see that what is causing the stresses. So that you can use also in traditional beam models, not only in the warping models. Okay. And if you want to know more, I just had webinar like 2 weeks ago. You can find it in the YouTube somewhere. So check it there. I don't want to talk more about this thing. Then we did a few modifications to user interface profiles. So let's see what it means. So first we have to look what we already have done. So this is an old development from 22 and 23. So we first develop windows, so we can have multiple windows and viewports to one model. So we can have like a single wall and single wall results and maybe something else here. Then in the bottom left-hand side, we can manipulate these windows. So we can duplicate easily windows and make a new window. And on the right-hand side of we have a save display status. We can save what is hidden and what is shown. And here we have a save all the other visualization settings. So what is like the style of visualization. And here in the top, we can arrange the windows really quickly. Like this also was already in the previous version. So this is the starting point. And the starting point is here. We can save display status. We can save view. We can manipulate the windows. And now, what is the new thing here? Let's imagine that we want to model a concrete in this model. So we go here, and we want to draw something like concrete wall, concrete beams. And you can see that the user interface of FEM-Design has a lot of buttons. We only need this button, basically, and we need this column button. And maybe the beam also, we want to draw concrete beams. So it's, okay. But we don't need the line connection or the surface connection. So we can hide those. So we can hide buttons, and we can show even hidden buttons, so we can hide the whole group, so we can simplify the user interface. And this is still like old. This already has been like the previous version. But now we can also customize these in the right and left hand side. So if we hide something here, maybe we don't want to see the others when we are drawing concrete. We don't want to see those buttons. And then we can save the configuration in the top right hand side of the screen here. We go to the configuration, and then we just give it some kind of name here. Let's call it like concrete design or concrete modeling or element input or whatever. We can call it wall input. And now it's saved, and now everything, even those tools on the left and right hand side of the screen, will be saved to the layout. So that is the new thing here. So what it means now, let's imagine that we want to input concrete. So now we have a custom UI. We can have multiple custom UIs in the software. So let's now imagine that we want to draw those concrete elements in the model. So we want to go here. Okay, then we want to start, and we want to simplify. We want to be really fast and efficient. So we have designed a layout called element input. Now you can see there's hardly any buttons in the software. So we have turned off everything unessential for concrete input, and now we can be really fast because there's only like 7 buttons in the software. So we have only column, beam, and wall, and maybe like line support. All we need to model the concrete. So nothing extra is there. So it's really fast to now work because there's no any unnecessary functions in the software. And if you don't like, you just go back to the default user interface in the top right hand corner. And same time, if you want to add steel features in the model, maybe we can make a new layout for steel input as well. So if you want to add steel here, we want to be quick. So we go here and we select the steel input user interface. No, we only have a beam and column and truss and support and point connection and cladding or cover, where we can input only these. And then it's really fast to model something because we only have like 4 buttons and nothing extra. And you can decide what is on the left hand side, what is on the right hand side of the screen, and what you don't want. And like this, it's much more easier to work when you only have necessary buttons in your model. And if you want to go back to the default user interface, you just go to the top right-hand side and select full, and there you are back to the beginning. And we can even simplify the results. So usually the result view is something, but there's like modification tools on the left-hand side of the screen, and there's like all the others. But if we simplify, we don't have to actually modify the structure when we are seeing the results. So now it's much more simpler. We don't need anything at the left-hand side, and now that is gone. And we only have the necessary buttons here. And in the concrete, if you want to design concrete, we want to simplify that one as well. So we can select here the concrete profile. Let's call it like this one. And here now we don't want to modify the structure, so we don't need those modification tools. So a few ideas about what you can do. So the new version will add the toolbars to the custom UI profiles on the left-hand and right-hand side of the screen. And you can increase the productivity because it's so fast to go between the UIs and even the right and left-hand side of the screen. Those dialogues will follow you. You can make it beginner-friendly. If you have a a new employee, you don't want to confuse the employee too much. You can simplify the software of somebody else. Or you can lock intentionally unwanted features like a surface connection or like fixture cells or whatever you don't want those beginners to use. And it's a full customization. So we could have done this before you, but basically you are the expert of your workflow. So that's why you have to do it yourself. So that's why it's a customizable. So you have to do it yourself, these profiles. And in 2 seconds, you can go back to the beginning, the full UI. Then we develop a new thing, what is called dialog presets, and it's also a productivity tool. And the baseline is version 23. So let's see how it was to model the concrete elements in the version 23. So first we draw the walls. So we have to input the thicknesses and all the properties, the eccentricity, the material grade, the creep factor, shrinkage factor, stiffness reductions, and then we can draw it. And you can see that it takes a lot of time to set those properties. And usually all the walls, they will share the same properties. And then we have to set the edge connections. And it was back in the days, it was done so that we just select those edges and set the specific types to the edges. So that is basically the baseline of productivity, what we are comparing against. So that's basically we are done. So in version 24, we did edge connection presets. So in version 24, we did a modification. You still have to set these thicknesses and creep factors and shrinkage factors and stiffness factors here. But now you can set those like edge connections automatically, so they are there already when you are modeling. So it will speed up a bit the modeling process of the concrete. Okay. And the new version, the 25, will introduce dialog presets. What it means that all of those settings inside of this big button can be automized here. So we can make this that it will include the creep factors, shrinkage, thicknesses, cracking factors, everything you input in the probably like many elements. And there you can see we can really boost up the productivity of the software. So you can see that the modeling time of the typical concrete structure has been reduced a lot during 3 years. Okay. What about if you have steel structures? Can you still benefit from the new version? I don't actually use the baseline, the 23 here, because that will be even more slower, because in version 23, what we are comparing against here, we already had the edge connection or the end condition library. So we have to still set these like this, and then we have to put like the spring values of those steel flange connections, and we have to set those, and also like the alignment, and then we set the columns to the model, and then we set the beams to the model. So let's say we use the I-beam here, and then again we have to set those like connection types. What is the bending stiffness of the connection, and then model the beams to the model like this. Okay, it took some time, but it didn't take that long. And also version 25 will include the dialog presets. So what it means that if you now see how fast it is to draw in version 25. So here we can, with 2 clicks, get all the settings for the beam, all the end connection spring values for the beam ends, and so on and so forth. And then we draw those beams. And same here. But of course, you have to have a repetition in the structure to use it. Otherwise, it doesn't help you at all, because if every beam is different, then it doesn't speed up at all. But usually the case is that you use like the same connection in 20 different beams. So compared to the 24, we have increased the productivity a bit. So if you don't tell your boss, you can leave like 2 hours earlier in the workplace. And if you like these dialog presets, by the way, they also apply to all the dialogs in the software. They apply to supports, connections, line connections, edge connections, anything. Any window now has these presets, so you can use it across the software, not just like beam and wall input. And there you can have it in the company settings, so you can share it with your friends, or make like good settings for concrete wall and cracking factors and so on. Then we did a small modification to diagrams in the software, and this is what we've done. So this is the default, and we have a new property, what is called graph fill, and it's located in the display in this display icon, what you can find in the top left-hand side of the screen. And this is how it looks like in version 24, and the new version will look like this. So it's up to you. It's you can choose. Especially in the complex structures, it might be easier to use these field style graphs. So, but it's up to you what you want to use. And here it's how it looks with the wall element connection. So here it's how it looks with the beams. So there you have it. Then we did some modifications to temporary files. So when you use the software, it will write the data to hard disk. So first you can compare the finite element calculation, and there's hardly any reduction in this part of the software. So if you calculate this big model, what is like 5 different buildings, include a lot of stuff, here is the temp file size. So in the finite element calculation, it doesn't affect a lot, because we did a lot of improvement in version 22. But if you do concrete design, here it really helps. If you see the temporary file size in concrete design between version 24 and 25. You can see the temp file size is almost like 30 or 20%. There's a question. The new FEM-Design should include more predefined presets in additional. Yeah, we can. That's a good idea. We could include like typical wall settings, like cracked wall with the shear, like typical concrete wall, and include all of those edge connections as an example for users. Yeah, definitely we can take that as a good idea to improve in the new version. And I know that there's coming new library items in the next release during this year. At least the soil library is coming, and maybe we can include the wall library as well. But anyway, you can see that the temporary file size in concrete design, if you calculate the wooden armor and auto reinforce plates, it has the hard disk use has been cut almost like to minimum. But calculation time, okay, we also have saved some time there. It takes less time to calculate big models, the wooden armor, but the biggest benefit is the hard disk use. And we have also speed up the reporting. So if you click the report button, go back to the model, click the reporting again, that is much faster in the new version. Regarding the steel fiber reinforced concretes, is there any plans to implement? Yeah, we have been discussing about it, but I cannot tell you anymore. But if you hack it, you can kind of use the new plastic shell feature to calculate the already now the fiber concrete if you are tricky. But you can contact me after the webinar. I can give you a few hints. Then we did some modifications to reporting. So in the reporting, when you have these like title blocks, you have a cover page and you have this header and footer of the documentation, like this part. Maybe you have a company, you have company logos and so. So now there's a new property, you can put it in the company folder. So there's a shared folder where you can put those title blocks and everybody then gets access to those. So you don't have to share them anywhere in the company. You just put the folder here and everybody gets them in the use if you're using big company. If you are working with the small company, it doesn't help you at all. But it's good to know that now it's possible to share across the company with the single property. This is really interesting, automatic parameters. So we have started to do those parametric models. It was like version 23 when we did the first development here. And the basic idea is that we don't want to compete with the API. This is just like much simpler, but also much faster to do. So first we have a parameter. So it's just a table of variables. Then we have a base ray or base plane. For ray is like 2D planes, and plane is for 3D objects. So it aligns the objects. Then we set the constraints. So we move those objects to base planes. And we can move those like planes and rays with the parameters. And then we can lock like beams or shells or solids to those base rays and base planes. And grid means repetition. If you have like n pieces of some part, then it's a grid. Let's see how it works in practice. So we have parameters, they are here. So this is already how we begin this. And this is the base ray. And for 3D parts, we have a base plane, and the grid is here if you have a repetition in 1 or 2 or 3D. And lock will lock the objects, and constraints will move those base objects. So the new thing is here is the automatic parameterization. So before it was so that you have to do everything yourself. So if you click, you have to first define those base rays and base objects. And here's the lock symbol. But this is the new. So now we have this new auto grid. So first we try without the auto grid. So this is how it was like previous version. So we have a lot of the same variable Z1 here. So it's really clumsy if you want to change the number of those fields in the trusses or like towers like here. But the new property is this auto grid. So now we can tell the directions. And if we paint over the same part of the model now, it's totally different. There's just one Z. And now if we go to the parameters, there's a new parameter, and this is this number, the division here. So we can set it to like 10, and let's see what happens. Like this, you can see that the division will change. Now we have 10 pieces of that truss, and we can change the height. Of course, we didn't paint over the top of the structure, so that doesn't follow, but it's easy to fix. Okay, and then we paint over the whole structure. We get the whole parameter set. So also the foundation will be parametricized automatically, and you have those properties and also the grid. Oh, there's a question: do we have an option to export bar node forces floor level wise? Yes, we have an option. We have a tool called list, and if you click list, you can choose like one level, or you can choose like selection. You can select like one floor, and then you can just get like those floor beams or one floor plate node transformations. So of course, but it's maybe I send you the answer after this webinar. It takes like 5 minutes to show, but there is a possibility. And then I just wanted to show how this grid works in case if the automation does not work. The grid is really fast. Also do yourself. Just draw the grid with the grid tool like this. Okay, and then give it like size. And then we assign objects to grid. So let's see that we want to assign these objects to this grid. And now it's done, and same here. These objects to this grid. So it's easy, very easy to do also manually like before. So, but now the new automation will help you. And now if you modify the division number, you can see that this truss type is a bit different than the other truss type. So you see the repetition because I included in the repetition just one part, and now there's two parts. So you can see that there's two parts of the same system. Then new feature is a parameter formulas. So let's see what we can do with those. We use the same example as we did before. And let's say that there's a column distance is this x3, and we want to have this outstand of the foundation equal to the width between the footing here. So now we can type the formulas. So we want to define the x1 with the x3. So we can call this like W. That W will equal to the distance between the columns, and now we can call this like C. C is the cantilever of the top beam. Now we can write the formulas here. I just changed the variables names so it's easier to understand. So let's type something here. Like here, x1, we want to define x1 so that the x3 equals x, this outstand of the foundation. And then you can type simply formula like subtraction, multiplication, or whatever you want to type here, like x1 equals w minus c. And now if you modify the w, the outstand of the foundation will be equal. So let's see if we do some modification to the model, like w here. You can see now the W and the outstand of foundation will be like same size. So you can lock those variables with the formulas. So how to use them? They are now in the input wizard, and that is also like improved a lot. So in the input wizard, you just press the input wizard, and then you can give the value of those parameters, and then you can use those. But let's look a bit more examples when we have looked what we have done here. This is probably also a feature what almost every user can use. So it's a parametric sections. So instead of drawing those sections yourself, if you have like repetition, you can also use parametric model to make sections. The idea is basically the same. So you have variables, you have a base race, and you have a constraints, and you have this lock. So constraint means that what variable we are using to move which base array. So we are using 2D example here. We want to do concrete section. So let's first draw region. Region is like 2D object in FEM-Design. So the button is here, region. And region can be anything like collection of arches and lines, but now it's a simple rectangle. Then we use base race to lock this rectangle. Like here, we put base race. And then we use the constraints to move those base rays. And first you have to give it a parameter name. Let's call this is the height of the concrete section, and this is and when you click it, you have to first click the master. So it means that the master will move the slave. So this is a master and this is the slave. So it's important what order you are defining the constraint. So which part of the section will remain like stationary and which part will move. So this is a stationary and this is a moving part. And only thing we have to do is lock it. So we right click on the corner of the section, and then we select two base rays. It's really important that you only select two, because if you select three, then it doesn't work, because only two rays will define exact points. And in 3D objects, you have to select exactly three. If you select four, it doesn't work. And now it's locked. And if you want to use it, you just click here, save for input wizard. So how we use them? This is probably you might be a bit difficult to find it yourself. But let's see. You click on the beam, and in the sections, there's a new button here in the new, and you click size. And there is the button. There's the parameters there. And then you click shape. And now we have a concrete rectangle here, what we just made. So you probably guess how it works. You just give the parameters, and then it works. You can make any size of concrete. So here are a few examples of modifications you can do. So if you want to do like this one and this one, so you can define really complex sections, as you can see here. It doesn't have to be simple. So we can do this, and you can just imagine how long it would take without the parameterization. So now we can really easily do structures like this. Or what about the holocaust? If you want to import a lot of holocaust to FEM-Design, now you don't have to. You just make one template, and then you can modify the size of your holocaust, and then you can just like few seconds you can make ultimate many sizes of holocaust easily. Or TT slabs or whatever you have. Or maybe you are steel designer, you want to do like double angles. So like we can parameterize the distance between the angles, the size, the wall thickness, the radius, everything what you have in section, you can put as a parameter with these instructions, and it's and then you can do like beefed up sections. You can do double angles. You can do like purlins. You can do whatever you want. It's really easy to do this, and you no longer have to draw every section yourself. You just make one like a template and use that as with the parameters to create ultimate many sections in your software. And the final cool feature is the parametric solid. So what this means is that you can also parameterize like 3D shapes. So here we have a pile cap. We have parameterized the pile cap, so we can change the thickness and the face length and the angle, whatever you want to, how you want to change the parameters. And like I told you, if it's a 3D body, you have to select 3 planes when you lock those. And you have to be really exact. The shape has to touch those like base planes intersections exactly when you are using 3D, but otherwise it's the same. Right click on the corner of the solid, and then with the loop you select 3 planes, and then it's locked in those constraints. So how you can use them? If you want to do those pile caps, we go here, we go to the point foundation or isolated foundation. Okay. And there's a new button, change shape. So the foundation can be any shape now. And there's a pile cap. Let's see how fast it is to use. So now we just give those parameters a value, so we can say that the side is like 50 centimeters, and like the thickness is this one, and you can see how fast it's now draw. This would take like 2 minutes to input in the old FEM-Design, and now it takes like few seconds, and you can do as many as you want. So here's your 3 pile cap made in few seconds, and it will look like this. So it's a pretty usable. What about the normal foundations? Does it speed up that one? Well, if we do this one, like rectangular foundations, so you can now set the width, height, thickness, and eccentricity of the foundation, and now it's really easy to draw. Like you can see that it takes just few seconds to draw the foundation. We just go to the rectangle foundation I just made, and then give these parameters a value, like what is the eccentricity of the foundation, and then you just set the orientation, and then you can put as many as you want in your analysis model. So now it's a fast to model those foundations. And it can be any shape. It can be pile cap. If you are using pile caps, please remember that the isolated foundation has a spring value. So that has to be set to a very small value. There's a question. Can the same parametric sections to be used both steel and concrete? Yes, it doesn't tell you what it is. So you can even do timber. So it's just a shape, and same applies to parametric solids. You can do whatever you want with them. It's not the parametric section module does not tell you that what is the material. They are just like geometric shapes. They don't have any material properties whatsoever. Okay. Then IFC 4.3 is introduced, and the huge focus is infrastructure, and we have followed that one. So we want to focus more on infra. So like we can now import 3 type of IFC infra objects. We can get like volumetric site geometry out of IFC. We can also get the surface type geometry out of the IFC, and also geographic element out of the IFC. And I can give you a few examples how you can use it. So you just go here, File, Open, and find some IFC which includes soil data. So we go IFC. Let's go to the landscaping. This is an example, pretty like a simple IFC example. But let's see if we can find any like 3D soil properties here. And we go here, okay. And there we have it. We have a geographic element of IFC. So we can input that one in the FEM-Design, okay. And the choice is here, what you want to do with. Do you want to bring it as a surface or with like a reference solid? But let's first input it as a surface and let's see how that works. So here's the surfaces of the geographic element, and let's try to make something. Maybe we want to do plates. So the surfaces is perfect for plates. So now we can do finite elements out of the IFC. So it's like this one and this one, maybe that. Okay, there is few surfaces as well in the tree. And now we have plates and we can just do finite elements out of those. But this is not very handy for soils. Well, we can try what happens if we try to do soil with this one. Okay, let's do the soil then. But for like surface objects like plates, this is really handy. But if you want to do soil for bedding modulus calculation or for the 3D soil calculation, we can now select surfaces. Let's see what happens if I click here. I try to make this as a soil. I just put simple friction like gravel here, friction soil, and use the same here and set one groundwater level like that. And you can see it just takes like one region because it's not continuous, so it's probably do not work. But if you select like all of those plates, maybe it works. But let's see it the other way. If we're using the other process, what we are using as a reference solid. So instead of selecting here as a reference object, now we select surface regions. So what happens now? It goes inside of software, and now it's a like single volumetric block inside of FEM-Design. So now it's much easier to do the soil, and it can be located in the layers. You can see it in the layers. There's a new layer, what is called reference solids, and it's there. And let's now try to do the volumetric soil model. So we just click here and click the volumetric object and set the same properties. So we set the default filling, and we get the strata. And this is what you do not get out of those IFC objects. You don't get layers. So that you have to, if you have a clay layer underneath like the gravel, that information you don't get out of the IFC. And there you have it. Now we have a volumetric object. And now we can calculate as a volumetric object. But you can see that now it collapses because the riverbanks are too steep. So it will cause a failure here because it's not the clay. Clay will have like glue-like properties, but this was gravel, so that's why it collapses to the river. But basically, you can calculate the slope stability or interaction of the building with the soil, or whatever you want to do with the 3D soil. And this is the ideal case how it should look like if you have a high quality topography. So the quality of the topography have to be really good because you're using it to create the finite elements. So this is how it works if you have like high quality topography as here illustrated here. If you just click here, it has to be continuous surface, and there you have a solid, really good. If you have a volumetric object, it works. And if you have this other example, you can also make a volumetric soil with that one. So that was for these, like if you have high quality, the points are not too close to each other, then you can make really high quality mesh out of those. And what else? We have done some other improvements for IFC as well. We have now IFC pile, because IFC files also include piles, so we support those. So if you find in the IFC pile, you can design what you do with it. If it's a beam, if it's a column, if it's a perfectly like vertical, it can be converted to column. But if it's a bit like angled, like few piles here, they can be converted to beams. So they are beam objects with the spring values. Or you can use them as a reference objects. You can convert to beams later if you want, or volumetric objects, or whatever you want to do with them. And also you can make the whole pile, if you have a pile caps and pile combinations, you can use them reference objects and then later convert this this pile cap to plate and these piles to beams or columns. Or you can convert them to isolated foundation, but please be in mind that there's always a spring value in the isolated foundation, so you have to put it like close to 0 if you're using piles. An IFC-based file means that now you can combine many IFC files to single analysis file. So for instance, if you have a heating equipment or you have a ventilation or you have a loading, like here we have an IFC space. So you want to import the loading data to your finite element model. You can import it later. The original IFC doesn't have to include it. So now you have already imported one IFC file, then you want to import a new one. You go here and paste file, and it's really easy to use. Now there's an option as an IFC. You can import IFC here. So it can be like your loading data or like ventilation equipment or whatever you have, pipelines or whatever can be included in the IFC. Then we also improved, if you have a really complex or hard to use IFC objects, we have used this IFC solid conversion tool. So first of all, when you import objects, you can select, are they reference objects here or are they like native objects like beams and slabs? But if it's a really complex, then you can maybe import them as a reference objects. And here is the example. We have an IFC file. This looks fine, but if you turn off the sections, you can see that it's actually not foundation, it's a wall. So it has been incorrectly written as a wall. So let's try to convert it to the plate, and that doesn't work. And if you try to convert it to the beam, like here, it doesn't work. That is not what we want. But there's a new tool. Now we can use solid, and we can, if something just looks right, but it cannot be converted, then you can convert it to the solid. Now it's a three-dimensional body, and that you can use to generate like plates. So for instance, this foundation bottom plate, you probably can generate with this bottom surface of foundation, because now it's the right size. And this base wall we can also generate with the side of the solid, and then we can align those objects together later. And now we have exactly the data model what we want in the finite element analysis. Just align the objects together and connect them, and then you are done. And I don't want to go too deeply into details, so if you are interested how to do those alignments of objects and correction of floating point issues and out of plane issues, I just kept webinar, so it's there somewhere in the YouTube if you want to find it. And other improvements we have done is that we have now support for IFC element assembly. So some software will put those IFC beams and slabs inside of assembly. So now that is supported. And IFC building element part is also now supported. So we can import even more like a different type of models. Then a few words, because the Revit link has been dead like few years, because the Revit redo the whole infrastructure, how they transfer the data. And we used to have the link to Revit, but now it's back. So we have done it again. So now it works. You can find it in here in the StruSoft tab inside of Revit. And you can export StruXML or import it, and also take into account the origin. If it's like far away from the origin, you can store the global system. And we have mapped those objects, like Revit level equals FEM-Design stories, and like the grids equal FEM-Design grid, and so on. It's pretty, and boundary condition equals supports, and it's pretty clear what's happening here when it writes those. Then we have a Revit model, and how it works in Revit. We can generate the automatic analytical model in Revit. And please keep in mind that this depends how good Revit is making those analytical models, so how good it is connecting those elements together. I still recommend that you watch the webinar I did like 1 month ago about how you align those elements together. So because it's up to Revit, we cannot control it. So there still might be some gap between the elements. So it's still beneficial that you know how to correct the model through the IFC, or just general how to correct the model. And here is how you can convert those element types together, how you can map the materials together in the Revit link, and finally you can map the sections, and you can make these default settings yourself if you are using the same type of models. And there you go, the Revit model becomes a FEM-Design model. And now it's up to you to use those correction tools to connect those objects together. Then we did some modification to buckling lengths of the steel, concrete, and timber design. So let's take an example here. in version 24, let's look the upper code. You can see that it automatically put in the beginning the buckling support in the weaker direction in the upper code. And of course, that's not correct. And in FEM-Design 25, the default setting is that if the direction of the bracing is not like supporting, then it's not taken into account automatically. So in the beginning, they would be like more correct. And same here, if you look like this column here, you can see that in version 24, it put automatically support there. But new version, it automatically recognizes that, okay, this is not a supporting member, so it's not taken into account. So you have to do less modifications yourself to the buckling lengths in the new version. The other modification we did that, okay, this is good to know that, okay, there's let's say that this is a supporting member, but in reality, you can see it's a crane track, so it's not supporting, it's not the buckling support. So you have to be careful. The automation can think that this stub of beam like 30 centimeters is a support, but in reality, it's not the support. You have to check it yourself, so please be careful. It's not full automation. And we always had this problem that when you stretch the length of the elements, it resets the buckling lengths, and that is no longer the issue. You can see that we have put the buckling lengths, these steel beams like here, 0.9. We have set the lateral torsional buckling and traditional buckling to here, like this beam. And if we now go to the modification of structure and we modify something, let's like change the location of this foundation and this beam, like this one, and then do another modification. We want to increase the height of the building. And version 24, now we would be like in big trouble because all of our buckling definitions would be gone. Let's increase the size of the building like with 1 meter. So now in previous version, we would be like, but now they should be like back to what we define. So here you can see that if we look at the strong axis, it's still 2.2. So it stretches those buckling lengths automatically. But here you can see if you go to the weaker axis, if there's a bracing member like here, then it doesn't save the value. So that is still like limitation. And same here, you can see that the buckling support and lateral torsional buckling support is still there even after the stretching of the structure. And final thing I want to talk about is the new cloud license system, what we have been developed. How it works, this only applies to network license users. So usually there has been like a need for local license server for. There's few questions. Sorry, I skipped those. Is there any update in the IDEA statica link? Sometimes the connection, I think you have had some problems. Maybe I don't know. That we have done a lot of small modifications. I haven't looked, so it might be bug fix if you have some bug between the IDEA statica link and FEM-Design. And if it's not in the major release, usually we do a lot of bug fixes like this in the service releases. So if you report the bug, we can probably fix it and get it in the software within few months. So if you just another question: can we perform two-way back and forth import export between Beam and StruSoft multiple times? We can do it both ways. We can write IFC and we can read IFC and write it, and we can also do same with the Revit link. And we have the GUID, the identification number of the beam, so we can save the link to the original member. It depends how much the other software will like change those entities. So if you, for instance, split the beam automatically or split the slab in the other software, of course, then it's split here. So how well it works between those software, it depends how the other software is handling those IFC entities. Especially with the detailing software, usually it generates like too much data. So it might work or might not work. You have to test on your own case how it works. But back to the cloud license system. So there's like two types of users. There's admins, which can create new users for the company. And then there's like basic users, which can just use the FEM-Design. And you can allocate licenses to users with this admin profile. And you can also take away licenses. And you can also return. If somebody forget to return the license, if you're admin, you can return it or forcefully take it back to the server. And you can even monitor the usage of the FEM-Design in your portal on StruSoft.com. So you go to this website and there you can see who is using those your FEM-Design licenses. So it offers a lot more flexibility in the use for the big companies. And how it works in the installation, if you are installing with the normal installation package, you have this option button, and then it's a question: do you want to have the new web-based license, or do you want to use the local server with the FlexLM? But if you are using StruSoft installer, so you are just updating the FEM-Design to 25, then you don't get this question because it's a silent installer. But if you install it through the file, then you will get this question, and then you can select the license system. And when you log into the FEM-Design and you have selected this web-based system, then the first question will be this: that what is your email address and what is your password? And if you have an admin in your company, admin can add these users or take away the users or like distribute the licenses to the users and monitor the use. And under the tools, this is a traditional local license. And if you have the cloud license, it will look a bit different. You only have this sign out button. So if you want to forcefully return the license, you can just press this button and then you don't have no longer the licenses. But it should return it automatically anyway when you close your software. But we still, just in case, put this button that you can return your licenses back to the server. But that's basically how it is. It's really simple to use. There's a question: when will be the cloud system be launched for FEM-Design? It's already offline. If you just install it with the installation package, you get this question this question. If you install it with the traditional installation MSC or X package, and then you get this question. Just select web-based, but then you have to ask us to generate the license. So it's already up and running, so you can use it. And this is the example how the portal will look like. So there's the first two buttons. There's a users, so admin can allocate users, and then there's the licenses. And if you want to view consumption, who is using the licenses, or return the license or take away license, if it's gets stuck, as admin, you can also return the license with this button. But that basically, it's really easy to use. Two buttons, users and licenses. And manage users under the users. So it shouldn't be too complicated to use for you. Okay, I think that was a lot today, and it was almost like 1 hour. So do you have still some questions? But of course you can ask later. We are there to help. But if you don't have any questions, we can end. And I thank you all for today. And if you have any suggestions for topics of the webinars, you can send them to me. See you in the next one. Bye.